Assalamualaikum and hi. My name is Zaty Sharif. My matrix number is AA221251 and my partner is Muhammad Hilman bin Abdul Ghani. Matrix number is AA221372. In this video, I'm going to explain about how to interpret a psychrometric charge for humidification. So first of all, we must to locate the dry bulb temperature along the bottom axis and associate vertical line for each temperature. It is called dry bulb because the air temperature is indicated by a thermometer not affected by the moisture of the air. Next, we must to locate the humidity ratio along the right vertical axis. The unit of humidity ratio are gram of moisture per kg of dry air. In other terms, it is called as mixing ratio. Step 3, we need to identify the saturation line. It is a place at the long of the curve from right to bottom. By finding the charged topmost curve line, we may be found the saturation curve. Then, locate the interior curve line. For step 4, to find the value of the relative humidity, follow the interior curve line to see the various level of relative humidity. Furthermore, on the right side of the chart, locate the vertical line labeled as dew point. Dew point is expressed as temperature and it is represented as a specific point where the relative humidity is 100%. Dew point doesn't change as the dry bulb temperatures varies. The vapor pressure line should be found to the right of the dew point. It expressed in inches of mercury or millibar. Next, look at the information on all sides of the chart, that is on the most extreme edge. This scale represents enthalpy expressed in BTU per pound of dry air. Lastly, look closely and find a second set of diagonal lines representing bulb temperature. Although the bulb lines are close to the enthalpy lines, they are not actually parallel to each other. In psychrometric chart, there are 6 components which are wet bulb temperature, specific humidity, relative humidity, dry bulb temperature, and dew point temperature. That's all for me. Thank you.
Okay, now let's look at the question. The problem is 100 meter cube humid air per minute enters a heater at 25 degrees Celsius and 40% relative humidity. Use a humidity chart to calculate the heat required to heat the air to 40 degrees Celsius. Okay, this is the chart after the plotting. Today we will use the formula of Q equals to delta H, or the difference of the enthalpy. Second, Q equals to delta mass flow rate of TA times delta enthalpy. Okay, let's look at the first question, which is find delta H, which is the specific enthalpy. Delta H equals to H out minus H in. First, we have to find H in at 20 degrees Celsius and 40% of humidity relative, and H out at 40 degrees Celsius. After that, H in, we got the H in, the specific enthalpy H at H in minus the curve of enthalpy, and then H out, we do the same thing, and then H out minus H in equals to specific enthalpy. Next, we find the mass flow rate. V in equals to 100 meter cube over meter in. So delta V equals to 0.855. The formula of the mass flow rate is delta AV in over V delta. We get the answer of 116.696 kgDA over meter in. Lastly, we do the energy balance. Q equals to the formula we state before. Mass flow rate times the specific enthalpy. So Q equals to 1634.42 kilojoule over meter in. Thank you very much. Thank you for watching. Bye bye.